Okay, so you will notice, ladies and gentlemen, that as always in your notes, this is what the question on the test would look like. Then there'd be a big blank space. Now on your notes, I show you everything you would need to do that. And then I always give you a shortcut. Your guys' problem is you don't bother really paying attention to this part, and you jump straight to the shortcut without understanding it. Then you get muddled up because you don't learn the real way to get somewhere, and then you hand me in work that is poopy. Do you understand? I cannot stress this enough. This unit is extremely easy to do only if you think about every single step and you recognize that every step is important, and you recognize that there are a lot of steps, and if you miss one, you will not have the right answer. Every step is easy, just like walking, but if you screw up one step along the way, you'll look stupid because you'll fall down the stairs and your friends will laugh at you. Probably before they even check if you're okay, because friends are not nice. Okay? A friend will say, "Are you all right?" And then when you say, "Oh, I think so," then they will laugh at you. Okay? That's the difference. The next time you fall in a group of people, look at who laughs. They're not your friends. Look at who looks slightly concerned, then sees everybody else laughing, and then starts laughing because they want to look cool around your friends. Okay? That is a person you could consider maybe to be a friend later on in life. Then look for the people that say, "Are you all right?" and check with you before they start laughing with all your friends. That is your best candidate. If somebody actually says, "Are you all right?" and then doesn't laugh at you, that's the friend. That's who you keep around. That's who, when you are locked up in New Orleans because you've gone to a Mardi Gras party and it's gotten a little out of hand, that is the person that is with you. Okay? It's not the person you call to come and get you out. It's the person that's already there with you. Understand?
Oh, yeah.
Okay. Now, you will notice that this rectangular prism, which, by the way, I will remind you, a prism is two identical shapes separated by rectangles. And we name them based on the shape that starts it off. So, in this case, this shape, I'm using this shape because it's the front, is repeated back here at the back. And in between them is a series of rectangles. Does everybody understand? So this is a rectangular prism because it starts with a rectangle, it ends with a rectangle, and there's rectangles between them. Everybody good? Aces. Now, this is how you do it. Remember, this is the longest way, but it is the way that guarantees correctness. You cannot do this wrongly if you follow this example. It is impossible, unless you don't belong in the 9th grade. Okay? So, you will notice that there is a front and a back. I have highlighted the front and the back as gray, and then I have put it over here. Correct? Excellent. What is the width of this gray rectangle? 6. Lovely. Well done. What is the length? 10. Lovely. Now, how do you do this so you don't screw it up? You write it down. Area equals LW. Correct? Great. What is L? 10. What is W? 6. What is 10 times 6? 60. And then the smart ones among you will recognize that there are how many of those rectangles? 2. So you must do 2 times the 60 that you got to get an area of 120. Does everyone see how to do it? Great. Fill in the rest of this chart. Now, you guys are smart kids. Every face of this figure is a rectangle. Every rectangle has an area that is length times width. Every rectangle on this shape occurs twice, so that means every area occurs twice. Then what do you do with all of those areas? Add them up to get a total of 276 centimeters squared. Why is it centimeters squared? Because there are 2 dimensions. Even though it's a 3-dimensional figure, we are only counting the length and the width of each side. So therefore, it is only 2 as an exponent because it is 2 dimensions. Karina first. Her hand has been up for a while, James, and then yours. Karina, hit me. Pardon me? Uh, 280. Yes, it is 376. Mr. Myers forgot to carry the 1. How embarrassing. Would you ever forget to carry the 1?
Yes.
Of course you would. But you use calculators. Does the calculator forget to carry the 1?
No.
No. James, is that what you were going to do as well?
No. Would that be the inside answer or no?
No. Because that shape, as I said earlier in the 9th grade, we are only thinking of the external surface area. Okay? Is everybody good? Great. I'm not going to give you the shortcut yet. Please turn the page over. Now you guys got to do the top one. Just do that one. Please notice I have not been nice to you and I have done no highlighting. You must figure it out. Just do A. And please notice I have added extra blanks to fill in. There's a reason, so fill them in. Was everybody able to do it? Everybody?
Yes.
Excellent. Does this need any explanation? No. Because notice that all you have done is done length times width times 2. Right? Okay. Look at the next one and tell me what's weird about it. It's a cube, which means all the sides are the same, which means technically, how many length times widths do you really need to do? 1. You do length times width, and then you multiply it by how much? 6. But of course, what are we doing? The long way. Why?
Because it helps us learn.
Because this is why it works. So when you get to more difficult ones, you have the ability to fix them. That is why when you are learning to fix an engine, for example, you start on a very tiny little one. And then, of course, you would add all that up and get 864. Now, is everybody good? All right. Now, this blank space right here, now I am going to allow you the shortcut. Please look in your notes. I think it is the very last page. There is a formula sheet. It looks like this. It looks like this. Let's go, computer. I'm in a rush. This is very embarrassing while I sit here and wait for you to decide to print what I want you to do. Ha! It looks like this. There's a rectangular prism, yes? Okay, so I don't think this will work. It didn't, damn it. That's okay. Draw a rectangle, draw 2 diagonal lines from the top corners, a diagonal line back from the bottom corner, and then connect them. Now I'm going to split my screen to show you what I am talking about. Please notice that this rectangular prism has been labeled with an H, an L, and a W. Yes? Does everyone agree? Again, you draw a rectangle. You draw a diagonal line from the right-hand three corners, then you connect those three diagonal lines. Does everybody see that? Now, isn't this a rectangle? Now, if it were by itself, it would be length and width, wouldn't it? But since it's part of a prism, we call it length and height. Is it the same thing? So how would you find the area of this that I've colored blue? You would do length times width, but in this case, you would write L times H, yes?
Yeah.
Excellent. And how many of them are there? Two. Good. How would you find this area that I have colored in purple? What is this? H. What is this? Width. So this would be HW, wouldn't it? And how many of them are there? Two. And how would you find this guy that I have done in red? LW. And how many of them are there? Two. And then you would add it all up, correct? Okay. Now, look at this. There is a formula. The formula is 2WH plus LW plus LH. Now, you guys, based on our previous unit about polynomials, are well aware that that 2 would go into all of these, wouldn't it? And I would get 2WH plus 2LW plus 2LH. And where do I find WH, LW, and LH? Right from the picture. So all you would need to do is fill that in. If you try to do it all at once on your calculator, you will screw up. Because what math is happening here and here? Multiply. What math is happening here and here? Addition. So if you punch this into your calculator wrong, by not doing BEDMAS, you will screw it up. Here's what everybody does. Every kid I teach goes W times H. They hit W times H on their calculator. Right? And then they do times L times W. Then they do times L times H. And their answers are wrong. Always. When you do a final exam, guess what one of the choices will be? The answer if you do times, 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 times. So on the test, you will see the answer that your calculator shows, won't you? And you will say, oh, there it is, there's my calculator, was 1,723. Because you will not be thinking. Do you understand? Good. Now, I remind you, if you know this, you can do the whole unit. If you wish to save yourself some time, you might wish to learn the formula. Okay? Cool? All right. Let's move it along, little doggies. The next page has triangular prisms. You already know what a prism is. It's a three-dimensional shape that has two identical shapes that are separated by rectangles, yes? So, This one is a triangle. And it is separated from the other triangle by how many rectangles? 1, the red one. 2, the green one. And 3, the light blue one. So what would the surface area of this thing be? Describe it to me with shapes. What shapes? What? I'm sorry, James?
Triangle plus triangle.
Triangle plus triangle. Are math guys lazy?
Yeah.
Damn right. So would they ever do triangle plus triangle?
So they do triangle times 2.
2 triangles
And then rectangle times 3.
plus rectangle. No! Because they're different rectangles.
Yeah, I get it.
So it is rectangle plus rectangle plus rectangle. Do you understand that?
Yeah.
Great. Now, what you need to do is put that into numbers. What's the formula for for one triangle? I gave it to you right there. 1/2 base times height. And how many triangles are there? 2. So all that needs to be multiplied. Plus, what's this rectangle? LW. Plus, what's this rectangle? A different LW. Plus, what's this rectangle? A third LW. Now, do all those LWs have a different letter? Yeah. But if you do this step by step, aren't they all just rectangles? And aren't they all just LW? Yeah. So let's go ahead and solve this puppy. There's a triangle, yeah? Okay. What is the base of the triangle? What is the height? 6. So we're going to write it out. Area equals 2 times 1/2 base, which is 6, and height, which is 8. Mr. Myers, you changed the order. Is that okay?
Yeah.
Why?
Because math is cheating.
Is 6 times 8 the same as 8 times 6?
Yeah.
Yes. So we're okay, aren't we? Now, some of you will look at that and say, oh, it's really hard to punch in my calculator. I don't know what to do. And some of you will look at that and say, hey, what does that 2 and that 2 do? Cancels out, leaving 1 times 6 times 8. Do I ever multiply anything by 1? No. So really the area here is just base times height, which is 6 times 8, which is 48. Cool? Everybody got it? Okay. Now, this gets snaky. According to the diagram, this is 10 and this is 4. Now, up until now, we've always been multiplying them by 2, haven't we? But not here. Area equals 10 times 4, which is 40. Now, are you all hopefully noticing that if you write it out, it's really, really hard to do it wrong, isn't it? And yet, most of you still won't write it out. What's this guy? Well, we know he's 4 across here, and we know he's 6 up there from the front, so it's 6 and 4. And the last one. And then what do I do with all those numbers? Add them up to get 144 what? centimeters squared. Why squared? Because it's area, and area always has 2 dimensions. Any questiones? No? Wow, we are on a roll. You guys do the next one. Go. You got to do that by yourself. You can race me. You have your calculators. I'll do it left-handed, and I'm still talking. Ready?
I'll do it left-handed too this morning.
Yeah, way to go, buddy. We already know you're faster than me. Go. Don't look at me. I'm on the last rectangle. I'm adding it up. Everybody ready? What do you have for an answer? 288. Now,
Okay.
I, on purpose, did 12 and 5, even though that's obviously the bigger rectangle. Why is that okay? Because as long as I do the rectangle somewhere, do I have it right?
Yeah.
Yes.
Doesn't matter if the dimensions might be different.
Is everybody good? Any questions? Erlen. Pardon me? You don't need to multiply it by 2 because of what we just proved. The 2 and the 1/2 cancel. Cool?
I can't. You shouldn't have put it left-handed. Oh, never mind.
But it's all written on there, right, buddy?
I just like.
Okay. Everybody cool? Yeah? Everybody? Okay. Now the next one causes kids trouble. Because the next one has a special name. Is a cylinder. What's this? No, it isn't. Because it's this. What is it? A cylinder. So is a cylinder still a prism?
Yeah.
Yes, because it's the same shape, a circle, repeated on the top and bottom, separated by what? A rectangle. Is everybody good? Now, since we already know that it doesn't matter what shape the prism starts with, we find the surface area by adding up all the sides, yeah? Well, is a cylinder a prism? Yeah, because it's a circle that's repeated on the top and bottom with a rectangle between it. So, if I know the area of this rectangle and the area of this circle on the top, do I know the area of the whole thing? Of course I do. Do we know how to find the surface area of a rectangle? Length times width. Do we know how to find the surface area of a circle? What is it? Pi r squared. So we know how to find the area of a cylinder, don't we? The top and bottom are what shape? Circles. Every circle has a radius. That radius is r. What's the area of a circle? Pi r squared. But a cylinder has how many circles? 2. So the area in a cylinder is 2 pi r squared. Right? Excellent. Now the curved surface is a bit of a problem. We know indeed that it's a rectangle, don't we? So if I drew this on your sheet of paper, you would call this length and this width, wouldn't you? But in a cylinder, this width we often call the height, don't we? So this width becomes the height in a cylinder, yes? What does your length become? The perimeter of a circle, which is called the circumference, yes? And circumference, we know, is pi times the diameter, correct? And the diameter is how many radii? 2. So this L must become the circumference. Correct? And the circumference, we know, is pi times the diameter, right? But we don't have a diameter. The diameter becomes 2 radii. So what I really have is 2 times pi times r. And that makes that rectangle. Does everybody get it? So this is 2 pi r. Then what do I do at the end of it? What did I do at the end of all the other prisms? We added up. So a cylinder must be 2 pi r squared plus 2 pi r. What's missing? I've only got the 2 pi r here. What have I forgotten? The h. We need the height, because remember, it's length times width. So I need an h there. Is everybody cool? Now here's what's going to screw you guys up. If I draw the cylinder this way, and this is going to be hard for some of you to draw an oval, a flattened circle. Draw 2 lines straight down from the side, and make a smiley face at the bottom. There's a cylinder, yeah? Yeah. Real easy to recognize that that's the height, correct?
Yeah.
If I turn that cylinder on its side, so now draw an uppy-downy squished circle, and draw sideways sides, and a half a bracket, where's the height now? It's here still. But some of you will take this r and say it's the height because it's going up and down. That would be silly, wouldn't it? None of you would do that, would you? Because of course you recognize that my height is 5 foot 8 inches tall, yes? Even if I lie down. Okay? Okay. I only do this because I am tired of 9th graders not recognizing that shapes can turn. I know, it's very confusing. For some strange reason, you guys can only understand a triangle that points straight upwards. Even though I gave you that whole worksheet where the triangles were turned. Everybody good up? All right, let's see if you're really good up. How do I do the area of a circle? pi r squared. Right? What is r? So it's pi times 3 squared. What is 3 squared? 9. So really, now we always like to put our numbers before our symbols. So it's 9 pi, yes? But there are how many circles? 2. So over here I know that it's got to be 2 times 9 pi, which is what? 18 pies. We are not going to go to our calculator. Why? Because you will screw up hitting that many buttons. We are going to, if it's a nice number to work with, we are going to leave it as pi. Because that makes it easy. Easy as pie. I know! Thank you, Liam, for recognizing that.
No problem.
The curved surface is what? That's h, and that's 2 pi r, right? Because the 2 r's get us the diameter, and then we need a pi. Correct? What was our r? 3. What is our h? We get it off the picture. It is 5. So this is 5, and this is 2 pi times 3, correct? What is 2 times 3? So that is 6 pi times, what's my height? How many pi is that? 30 pi. I have 18 pies, and then I have 30 more pies. If I told you to add this, 18x plus 30x, what would we have? 48 x's. So what do we have here? 48 pies. Now do we go to our calculator? Yes. Before we go to our calculator, what should I do? I should estimate. What's 48 close to? And what's pi close to? So my estimate is 150, yeah? Let's go to our calculators and see. Bum, bum, bum. 48 times pi. 150.796, which is what, James?
150, it's 80.
150.8. Is that pretty darn close to 150?
Yeah.
Yeah. Now, please notice this piece of information.
Notice.
If the centimeters are in whole, you can go ahead and leave it as 151. So it would have been 150.8, right?
Mm-hmm.
Is that pretty close to our estimate? So we know we did it right. You guys do the next one. when you have an answer, which you are going to stop at, it is the answer with pi. Does everybody have it? I will wait a moment to make sure you all do. Does everybody have an answer involving pi? Would anybody like to share that answer? Going once. Going twice. 3 times. No one? 80 pi. Oops. Was everyone able to get that? If you were not, you need to figure out why by looking at my work over here. Now, before you go to your calculator, what should you do? Estimate. 80 is a nice number to multiply, yeah? 80 times, what's pi close to? 3. So my answer has to be close to 240. Will it be bigger or smaller than 240? Bigger, because pi is really 3.14, isn't it? So as long as I have a number that's close to 240, but bigger, have I done it right? Yes. Great. So go to your calculator. 80 pi. Some of you don't even need to hit times. Some of you can just go 80 pi equals 251.327. For our notes, it'd be 251, wouldn't it? What if 251 isn't on the test? What if all the answers are rounded off? You would check for each one. If it was to the first decimal, it would be 251.3, wouldn't it?
Yeah.
Second decimal?
251.33.
251.33. Third decimal? 327. And it would never go further than that. Everybody cool? Erlen.
Can you do that on
The what thing? The top and bottom. This is one of the circles, right? Pi r squared. 4 times 2 is 16, 16 pi, yeah? But because there's a top and a bottom, we got to do 2 pi r squared. Right? Cool? Everybody feeling good? Everybody feeling strong? Strong like bull? Roar! 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 He's making bull horns with his fingers. It doesn't work unless it's explained. Okay? Go. Your work is, of course, outlined for you. Oh, it's not! Damn it! I gotta print you the worksheet. Ah.